Imagine this. It is July 4th, 2039, and high above the rust-red plains of Elysium Planitia hangs a 500-ton stainless steel monolith the size of a 40-story building, its 9 methane-oxygen Raptor engines already glowing dull red from the heat of entry, falling belly first through the Martian sky at $900 mph, while the ground races upward at a rate that would make any sane pilot reach for the eject handle that does not exist. This is the fully loaded Starship HLS-3 carrying 180 colonists, 120 tons of cargo, and enough hope to seed an entire civilization. And in the next 8 minutes, it must shed every last joule of its 3.8 gigajoules of kinetic energy and 1.2 gigajoules of gravitational potential without turning itself into the largest impact crater since Hellas. There are exactly 7 insane, physics-defying engineering nightmare ways this beast can possibly survive the ordeal, and in this single, continuous 13,000-word paragraph, we will live through every one of them in explosive 3D detail. Calculate the exact thrust curves, heat fluxes, deceleration profiles, and failure modes, so that by the time the dust settles, you will know not only which method humanity actually chose, but why every single alternative was attempted, tested, or quietly buried in the Utah desert. Because landing 500 tons on Mars is not a gentle kiss with the ground. It is a controlled detonation that must stop exactly 1 centimeter above the regolith. Method 1. The original suicide burn. We begin with the purest, most terrifying way Elon ever drew on a napkin. Light all 9 sea-level Raptors at the last possible second and decelerate from 1900 mems to 0 ms in one continuous 62-second burn that peaks at 7.2 degrees and slams the heat shield with 1.4 MW2 of convective hell. The timing window is exactly 0.8 seconds wide. Ignite too early and you hover, run out of fuel, and fall. Ignite too late and you lithobrake at 200 mems, creating a 300-meter crater and the most expensive fireworks in history. The 3D simulation shows the ship belly flopping through the thin 6 mbar atmosphere, plasma sheath glowing white. Then at 1.2 kilometers altitude, the engines roar to life with a 4,100 kN wall of fire that turns night into noon across half the planet. The shock diamonds stretching 800 meters behind while the vehicle decelerates so hard that coffee cups orbit the cabin and every colonist blacks out for 4 seconds. The landing legs unfold in the last 2 seconds, titanium struts extending like a spider's limbs, and the whole stack kisses the ground at 0.8 ms with 1% propellant margin. SpaceX actually flew this profile unmanned in 2031, 2033, and 2035, each time shaving the margin thinner until the 2035 attempt ignited 0.4 seconds late and excavated a 42-meter hole. The suicide burn is elegant, minimal, and absolutely unforgiving. 1-bit flip in the flight computer, and 500 tons become archaeology. Method 2. Supersonic Retro-Propulsive Split-Body. After the 2035 crash, NASA forced a redesign. The new trick is to split the ship in two at 18-kilometer altitude. The forward crew cargo section separates on pyros, while the aft propulsion module stays attached to the heat shield and performs a brutal 11G retro burn starting at Mach 6 bleeding velocity until it is a flaming meteor no more, then flips 100 eoic at 4 km and lowers the crew section on a 200-meter carbon fiber cable like a yo-yo while still firing engines to hover. The 3D animation is pure insanity. 2 halves of a skyscraper spinning in opposite directions connected by a glowing tether. Raptors on the booster module throttling between 10% and 120% in millisecond bursts to keep the cable tension between 80 and 120 tons. The crew section dangling like a gondola beneath a rocket-powered balloon. Touchdown is staggered. Booster lands first 400 ms upwind, then gently lowers the habitat to 0.3 ms. The advantage is that if the booster fails, the crew section still has 4 gimbaling Raptors for a softer suicide burn. The disadvantage is that the cable glows yellow hot from atmospheric friction and must be cooled by a blade of ice sleeves. The first manned attempt in 2037 succeeded, but the second in 2038 snapped the cable at 900 meters altitude and scattered 82 colonists across a 3-kilometer radius. The split-body method is now banned for humans, but still used for cargo because the booster can be recovered and reused. Method 3. The inflatable hypersonic decelerator, Sky Crane. Lockheed Martin's answer is to never touch the ground with engines at all. At 45-kilometer altitude, a 42-meter diameter toroidal balloon inflates in 11 seconds using nitrogen stored at 300 bar, increasing drag area by a factor of 180 and turning the ship into a giant parachute that slows from 2100 ms to 120 ms in 90 seconds, while peak heating drops to 380 kWh. Then, at 2.5 kilometers, 8 carbon fiber legs unfold into a Sky Crane truss, 4 Raptors ignite on the corners, and the entire 500-ton stack hovers while a 120-meter braided Dyneema cable lowers the habitat section at 3 ms until it kisses the surface, after which the Sky Crane flies 10-kilometer away and deliberately crashes. The 3D simulation is breathtaking, the balloon glowing orange like a second sun, the truss unfolding like a blooming metal flower, the habitat descending in perfect silence because the engines are too far above to be heard. The method was perfected in 2036 with a 120-ton test article and became the baseline for the first 40-person colony in 2040 because G-load never exceeds 3.2 Earth G and there is no engine-out risk directly above the crew. The only drawback is that the balloon mass is 28 tons and is single-use. Method 4. The Rotating Detonation Wave Engine plus legs. Blue Origin's dark horse is to replace conventional Raptors with Rotating Detonation Wave Engines, RDWEs, that achieve 108% of theoretical ISP by running the combustion as a continuous supersonic detonation front, spinning around an annular chamber at 20 kHz. The result is 4%. More thrust from the same propellant in a cooler exhaust plume that does not melt the regolith into glass. Landing is a classic belly flop flip at 600 mph, followed by a 58-second hover slam using 12 RDWEs throttled down to 8% where the detonation frequency drops to 2 kHz and sounds like the universe's angriest didgeridoo. The 3D cutaway shows the spinning shockwave glowing neon blue inside the chamber, pressure gain pushing chamber pressure to 42 MPa, and the landing burn creating a perfect 40-meter wide glass pad beneath the ship. The method was first flown successfully in 2041 and is now the preferred technique for night landings because the blue exhaust illuminates the surface like daylight. Method 5. The Magnetohydrodynamic Re-entry Shield plus airbag cluster. A wild card from the European Space Agency. Instead of a rigid heat shield, deploy a 60-meter diameter superconducting magnetic loop that generates a 3 Tesla field ahead of the ship, ionizing the atmosphere into a plasma bow shock that is pushed 25 meters forward, reducing peak heat flux on the hull to 42 km/h. The ship enters nose first like Apollo, then at 8 kN deploys 46-meter airbags filled with helium-3 mined from lunar regolith. The whole stack falls the last 800 meters at 38 ms, hits the ground, bounces 3 times like a rubber ball, and rolls to a stop across 1.2 kilometers of Martian plain. The 3D simulation is surreal, a glowing purple magnetic bubble surfing the atmosphere, then a colossal beach ball Starship bouncing in slow motion while dust plumes rise 300-meter high. The first test in 2042 worked perfectly with a 90-ton mock-up, but the second in 2043 popped 11 airbags on a hidden boulder and rolled the vehicle onto its side, rupturing 3 methane tanks. The method is now reserved for emergency landings on unknown terrain because it needs zero propellant for the final descent. Method 6. Supersonic Retro-Thrust with grid fins. Wapal crushable legs. SpaceX's 2044 compromise, keep the classic heat shield entry, but at Mach 4 deploy 4 titanium grid fins the size of tennis courts, using them to pitch the ship engines first while still supersonic, then ignite 3 center Raptors at 100 ms and 12 km altitude for a continuous retro burn that transitions seamlessly from 5G to 1G without ever flipping. The landing legs are 18-meter telescoping aluminum-lithium honeycomb designed to crush 4 meters and absorb the last 12 ms if engines cut out. The 3D animation is pure ballet. Grid fins glowing cherry red, the ship standing on a column of white fire while still faster than sound, shock diamonds punching through the Mach cone, then the legs stroking like a cat landing on its feet. This became the standard for the 2045-2049 Mars fleet because it combines the reliability of retro-propulsion with the aerodynamic control of wings and a built-in mechanical backup. Method 7. The nuclear drag sail plus parachute plus final hop. The most politically incorrect but cheapest method developed jointly by Roscosmos and the Chinese National Space Administration. After a nuclear thermal kick stage departs Earth orbit, the ship coasts to Mars, then deploys a 1-kilometer diameter mylar sail coated with 100 grams of americium-241 that ionizes the sail and creates a 0.8 Tesla magnetic drag loop interacting with Mars's own magnetic field anomalies, slowing the vehicle from 6 km/s to 900 ms over 3 orbits using zero propellant. Then classic disc gap band parachutes open at 14 km, followed by a 2-second Raptor pulse at 80-meter altitude to kill the last 60 minutes. The sail is jettisoned and burns up like a shooting star. The 3D visuals are haunting. A golden sail the size of Monaco glowing with alpha particle ionization, slowly spiraling down through the pink sky. Parachutes blooming like jellyfish, then a final blue-white flash as the engines fire for 2 heartbeats and the ship drops the last 8 meters onto crush cores. The method is radioactive, politically toxic, and 41% cheaper than any chemical alternative. It was used for the first 200 cargo ships between 2040 and 2047 before being quietly retired when the treaties caught up. By 2049, humanity has tried all 7, lost 312 lives and 41 ships learning the hard way, and settled on a hybrid that takes the best from each. Supersonic grid fin retro thrust for control, inflatable volute for heat reduction, crushable honeycomb legs for mechanical backup, and a small nuclear isotopic drag sail for the final orbit trim. The success rate is now 99.9997%, and the red plains are dotted with hundreds of upright starships, engines cold, doors open, waiting for the next wave of colonists who will never again have to choose between arriving alive or arriving at all. The physics has been tamed. The explosions are now only in the simulations, and the 7 insane ways have become 7 chapters in the textbook titled How We Learned to Land on Mars Without Dying.